This is a topic on direct proportion. I will give you some simple examples on direct proportion. Some things that we have covered in primary school before, and you've seen me write on the board many times also. 1 apple costs 50 cents. $50. 50 cents. So 7 apples cost? Well, how do you do this? 50 cents divided by 1 times 7. So you get $3.50. Yes? Right? This is an example of direct proportion. As one increases, the other increases. You just need to multiply to get the answer. Another example, instead of money, what else do we have? What else do we have? Okay. One question, correct. 3 marks awarded. So 15 questions correct. So how many marks awarded? How many marks? 45. So 3 times 50. All we need to do is to just multiply to get the answer. Or if you like, it is 3 over 1 times 15. Okay? So direct proportion exists in our daily lives, especially in the case of money, where you go do your groceries with your parents. Okay? So nothing to be nothing really complicated over here. So there's a video for you to watch. Just go and watch it and fill in the blanks. Now, I want to talk about this part. When we have cases of direct proportion, it tells us that, okay, in this case, if I were to tell you, please copy this now. If y is directly proportional to x. This is for the case if y is directly proportional to x. Okay, copy this down. What this means is that, let's say y is the total cost and x is the number of apples. Would you say that the total cost is directly proportional to the number of apples that you buy? The more you buy, the more it costs, right? Buy 3 apples, then cost times 3. Buy 30 apples, cost times 30. So when the value of x increases, what can you expect for the value of y? It must increase also. So that is in the case of directly proportional. Then what do you think happens when the value of x decreases? When let's say you buy fewer apples, what will the total cost become? Increase or decrease or stay the same? Must be decrease. So decreases. So when the ratio of two values of x is equal, when the ratio of two values of x is equal to the ratio of the corresponding values of y, we say that two quantities x and y are in direct proportion. I'll elaborate later as we go through. Now, can you guess what this, if I were to plot a graph, x and y, what do you think the graph will look like for direct proportional? When one increases, the other increases. What do you think the graph should look like? Up, going upwards, straight line, curve? Straight line. Okay, so it will look like this. This is the graph of a case where y is directly proportional to x. So as you can see, as your x increases, the value of y will also increase. As your value of x decreases, the value of y also will decrease. Since this is a straight line, can you tell me the equation of the graph? Y equals to mx plus c. So let's do a recap. What does m stand for? Gradient. What does a gradient tell me? How steep? Yes. If it is a positive value, then what does the slope look like? Yeah, going upwards. If it is positive, it's going upwards. Is this a going upwards graph? Yes, so we expect this to be positive. It is a positive gradient, but I don't know what it is. But I know it is a constant and it is positive. What about this c over here? What does this tell me? What does the c tell me? Okay, y-intercept. In this case, what is my y-intercept? Can you see that from my graph, the y-intercept is 0? If you buy 0 apples, how much will it cost you? 0. If you get 0 questions correct, how many marks do you get? 0. So it must be 0 in this case. So my graph equation is now simply y equals to mx. Okay, it does not depend on the y-intercept anymore. Okay, so we'll just fill in the blanks over here. When two quantities x and y vary in such a way that y over x equals to k, where k is a constant. I'm not going to rewrite this, and I want you to do it with me as well. Y over x equals to k. This tells me, put an arrow that y equals to, what do you think y equals to? Kx. Y equals to kx. Is this a straight line? Will this give me a straight line? Y equals to kx. Y equals to kx. Let's compare with what we learned last year. Y equals to kx versus y equals to mx. Do they have the same form? Do they have the same form? Yes, our k is simply our gradient this time. So whenever you are able to write this, y equals to kx or y over x is equal to k, where k is a constant, x and y can be said to be in direct proportion, or y is directly proportional. Kai Jie, have you written it down? So the equation relating y and x will be y equals to kx, where k is constant. Then the graph of y equals to kx is a straight line passing through the origin, passing the 0, 0, where the x and y axis meet. Any questions so far? Okay, moving on, next page. Here we have a table of values. Determine if they are in direct proportion. Okay, I see that as my x increases, my y also increases. So it seems like they could be directly proportional, but I cannot confirm yet. If they are directly proportional, I need to be able to write it in a way y equals to m of y equals to kx. Okay, directly proportional means I can write in the form y equals to kx. Am I able to do that? So if they are directly proportional, then y over x must be equal to k. Okay, if they are directly proportional, then y over x must be equal to k, where k is a constant. So this is how we test whether the values x and y are directly proportional or not. Take the y divided by x, you get a constant, then they must be directly proportional. So let's do a check. Y over x. In this case, we've got 30 divided by 10. Okay, these two come in a pair. 30 divided by 10, you get 3. What about the next blank? 60 divided by 20, you get 3. 90 divided by 30, you still get 3. 120 divided by 40, you still get 3. So what does this tell us? Yeah, it tells us that they are directly proportional. And what is the value of k? If I ask you now, what is the value of k? Yeah, k equals 3. So just put it at the side, k equals to 3. Okay, next, the other method is to find the ratio of x1 and x2. Well, all these are our x values. This can be x1, this can be x2, x3, x4. These are all our coordinates. So it has a corresponding y1, y2, y3, and y4. You can put all of them down. So x1 over x2 equals to 10 over 20, which is half. y1 over y2 gives me 30 over 60, which again is half. Since x1 over x2 equals to y1 over y2, which is half, x and y are in direct proportion. Straightforward enough. So two methods, up to you to choose. Then we have one last method, which is drawing a graph, which I don't think you would like to do, given a choice. But sometimes we get data only. I get data like this. Maybe I do an experiment. Then I can't really tell whether there's a relationship or not. So I plot them out. Plot them out over here. So here we are ready to fill in the blanks. What is the shape of the graph? Straight line. Does it pass through the origin? Yes. For those who are here already, since this is a straight line, I can write it in the form y equals to mx. Need to plus c or not? Need to plus c? Farisha, do I need to plus c? No need. Why? Why? What did you say? Farisha, what did you say? So what? C. Those who are seated down, make sure you're thinking also. No need to plus C. Farisha. No need. Why no need? Not sure. What does the C represent? Huh? Constant is constant, variable is variable. No such thing as constant variable. Okay, so what does C represent? Y what? Y-intercept. Yes, you are right. It represents the y-intercept. What is the y-intercept in this graph? What is the y-intercept in this graph? 0. So need to plus C no? No need lah. So this is my graph. Y equals to mx. As x increases, y increases. Now, what does this n represent? Jiahui, what does n represent? Jiahui, who's Jiahui? Ah, okay, what does, you all change place? Okay, what does m represent? Gradient. Okay, how do I find the gradient from this graph? Remember last year I told you the formula for gradient? Let me help you out. y2 minus y1 divided by x2 minus x1. Okay, you get to choose. What's your x2, y2, x1, y1? Which point would you like to use? Choose a point. You choose point number 1, 2, 3, 4, or 5. Which point would you like to choose? Huh? 3, okay. She chose point 3. What are the coordinates over here? (20) and 60. Okay, good. So y2 will be 60 minus, what is your other point? Point number 1, 2, 3, or 4? 4. I choose something easier lah. Something easier. Point number 1. So what is the y coordinate for point number 1? 0. Divided by 20 minus 0. What do we get? 3. Didn't this appear a few times already? Over here, k equals to 3. Okay, so that gradient over here actually tells us the relationship between the x and y values. Now, since the graph is a straight line passing through the origin, x and y are in direct proportion. When y varies with, okay, let's change this. When y is directly proportional to x, we can write down y equals to kx, where k is a constant. It is a straight line passing through origin, and gradient equals to k is n grams. So n chocolates weigh n grams. They are in direct proportion. Does it make sense to you that they are in direct proportion? Does it make sense? If one chocolate weighs 10 grams, 2 chocolates must weigh 20 grams. 10 chocolates must weigh 100 grams. That is direct proportion. It's a primary school type of question. Just that right now, we are using the terms direct proportion. Seems like it's confusing you, but no. Later on, we learn something called indirect proportion. Then things will change already. So that is why you need to be very sure about these terms. When n is equal to 15, m equals to 180. Before we look at the question, what are you tempted to do once this information are given to you? N equals to 15, m equals to 180. What do you think you can find out first? using our primary school maths, n pieces have mass of m grams. N equals to 15, m equals to 180. What does that tell you? Let's do a substitution. N equals to 15. So 15 pieces of chocolates have a mass of 180 grams. What does that mean? What can you find out? One piece. You can find the mass of one piece, isn't it? Okay. So we all understand the question, but that's not what the question wants. Part A. Express m in terms of n. Express m in terms of n. When I see this part, please highlight this. N and m are in direct proportion. Highlight it. So I know it is going to be something equals to k times something. You need to fill in the blank. Something equal to k times something, because we found that in the previous page, when y is directly proportional to x, I can write down y equals to kx. Confirm can write that. So I want to write it over here. Since they are in direct proportion, something equals to k times something. Now, should it be m equals to k times n or n equals to k times m? What is dependent on what? Which one is dependent on which one? M is dependent on n. M is dependent on n. Because as the number of chocolates increases, your mass is going to increase. So you must be able to write this down from the question. M equals to Kn. Okay? So now we're ready to do part A. So M equals to K times of N. You introduce the K in. It is now your job to find out the value of K. And it is not difficult to find the value of K. All we need to do is to just substitute. M is 180 equals to K times of 15. K equals to 180 divided by 15 to give us 12 grams. Or rather, let's just leave it as 12. So from here, I know that I can substitute this back inside here. M equals to 12n. This is the relationship between m and n. So you just take another color pen, just put on the side. This represents mass of one piece. Okay? Before secondary school, you would have taken 180 divided by 15 to get a mass of one piece anyway. And this is what it means. Now that we have this, we can do part B. Find m when n is equal to 20. So m equals to k, which we found k to be 12. 12 times of n, 20. So we get 240. And part C, find n when m is 84. 84 equals to 12n. N must be 84 divided by 12 to give us 7. Okay, do you highlight this? Do you highlight this? Okay, then at the top, what can you write? This highlighted one can be converted into maths. So what will you convert it into? Do all of you have y equals to v? Yes. V equals to k times of 3r minus 5. Do all of you have this? Check your partner's work. Did they write that? If they haven't, make sure they write it down. Must be exactly the same. V is directly proportional to 3R minus 5. Just copy down only. Next step. Oh, they tell us that V equals to 5 when R equals to 10. Look at your equation. You got 1, 2, 3 unknowns. V, K, and R. But the question gave us V equals to 5 when R equals to 10. What do you think you are expected to do? Sub in. Yeah, sub in. Come on, let's sub in. 5 equals to K times of 3 times 10 minus 5. Equals to K times 30 minus 5 is 25. So what do you think you should be doing after you substitute? After you substitute, what do you think you need to find out? Obviously, you have to find K, right? That's the only unknown. Might as well find K. So K equals to 1 over 5. Now that I know K is equal to 1 over 5, what is therefore the value of V when R is equals to 3? I'm now going to put this K equals to 1/5 back into my equation over here. Okay, so my equation now becomes V equals to 1 over 5, 3R minus 5. This is my new equation, and it governs the relationship between V and 3R minus 5. So V is directly proportional to 3R minus 5. Now R is equals to 3. Substitute in 3. So V equals to 1 over 5, 3 times 3 minus 5. That gives us 27 minus, 9 minus 5 is 4. We get 4 over 5. Understand? Yes? You have a problem? Any questions? Then now we can do part B. Once you have found your value of K and you have written this down, it is useful for our subsequent parts of the question to use it again. Okay, so I'll remove this part. I'll start with part B over here. Find the value of R when V is 24 over 5. Substitute in. 24 over 5 is 1/5, 3R minus 5. And we see that this goes back to our manipulation. We have to solve for R now. What shall we do with both sides of the equation? To find R, what shall we do with both sides? What? Times 5. Okay, times 5. So we get 24 equals to 3R minus 5. Yes? What next? What next? To both sides, what should we do? Plus 5. So 3R equals to 29. R must be 29 over 3. Done. C over X equals to 14 over 2, which is 21 over 3, which happens to be 35 over 5, which is 49 over 7, which is 70 over 10, which is 7. Since they all give me the same value of 7, since C over X is a constant, X and C are in direct proportion. So part B, what is the equation for X and C? Even without doing part A, you already know the answer. What is the equation like? C equals to Kx, okay, Kx, what is the value of K now? 7x. C equals to 7x, this is the answer. As your X increases, we multiply by 7, we get the value of C. So now find the total cost for 13 shirts. This is still yeah, okay. So for 13 shirts, C must be 7 times 13 to give us $91. and y. Look closely at the first table of values. Are they in direct proportion, x and y? Look at the values, x and y, are they in direct proportion? Wow, so far you can tell it's not already. 14 divided by 2 is 7. 56 divided by 4 is 14. Yes. So do I need to carry on? No need. This one, not in direct proportion. Not in direct proportion. Okay, then let's plot the graph of y against x. Are you able to see the lines? Can? Okay, let's plot quickly. 2 and 14. 2 and 14. 4 and 56. 6 and 126. 10 with 350. Okay. So 4 square gives us 16. Now plotting the graph of y against x. So this is a straight line. This results in a straight line. I will continue with the next part during our next lesson.